Good morning. This is last video for your oral preparation. So that is of column. Actually, I already shared you one video of column, but their design is not there. So we have three types of columns. So first we have that is axially loaded column. Axially loaded. Second, we have axial load plus uniaxial moment. Axial load plus uniaxial moment. Uniaxial means moment along one axis. And third, we have axial load with biaxial moment. Axial load plus biaxial moment. So we have these three columns, and now we will see how we will go design of these three columns. Now axially loaded column. So generally this column we are going to design it as axial load with minimum eccentricity. So you have given value of Pu is given to you. Then B will be given, or you have to assume B equal to width of support. For rectangular column. For square column, we need not require to assume any value of B. Then now we know Pu B. Now we have formula Pu is equal to 0.4 FCK Ag plus 0.67 minus 0.4 FCK into ASC. So now keep in mind, we have formula Pu 0.4 FCK AC plus 0.67 FY ASC. We have this formula. I have put value of AC that is equal to area of concrete is gross area minus area of steel. And therefore, we have subtracted from this. Now we have to assume value of ASC. Assume ASC. And we know ASC, this is area of steel in compression. We have for longitudinal reinforcement 0.8 to 4%, actually up to 6. But to avoid practical difficulties, we are preparing 4%. So let us, I will assume ASC equal to 1%. And this is percentage of AG. So 1% of AG means it is 1 by 100 of AG. Now we will substitute this value in this equation. So we have Pu equal to 0.4 FCK AG plus 0.67. Sorry, this is 0.67 Fy. So 0.67 Fy minus 0.4 FCK. And then we have this will be Ag upon 100. And then we have to take Ag common from this, and which will gives me value of Ag. This is equal to Pu divided by 0.4 FCK plus 0.67 Fy minus 0.4 FCK upon 100. This 100 is only for this portion. And then from this, we will get value of Ag. So Ag, we will get from this step. Ag value from this step. And knowing value of Ag, we can find value of D, because we know B, so AG equal to B into D. Now B we know, then we can get value of D equal to AG upon B. If we have square column, then B is not there. Then this is for rectangular column. For square, we can have B equal to D, which is equal to under root of AG. So from this, we are going to get the dimensions of the column. Sometimes you may have given L effective, then also we can get B equal to L effective by 12. That also we will have, and then with knowing B, we can calculate D. So now knowing value of B and D, then we have to round up it, and we have to provide B and D. Provide B and D after roundup. After roundup. Then you have to go for ASC. Then how we will find value of ASC? So ASC we will get, which is equal to, already we have seen AG upon 100. And that is AG we have to take from here, not AG provided. Do not take this. So AG provided you have B into D. So here we have to take it as AG required. So this value we have AG required. So you have to take it as AG required and then provide number of bars. Provide number of bars. We have 4 for rectangular minimum. Minimum 4 for rectangular and 6 for circular. And then we have to go for this. Now C condition for circular to increase 5%. That condition is given. You can go design of circular column in class notebook. Design of circular column. Where we have that condition. Now I don't remember whole, that is 0.36 something like this one. So we have to find core and all this. So I will not go in detail with that one. You can go and you can see that one. So this is first design of axially loaded column. Examiner may ask you what is formula for purely axial load. So purely axial load. So we have used this. PUZ, purely axial load, which is 0.45 FCK AC plus 0.75 FYASC. So this is purely axial, no moment. Purely axial. And this value we are going to reduce by 11%. Already I explained this, 11%. And therefore we will get this formula after reduction in by 11%, 0.4 FCK AC plus 0.67 FYASC. So you are going to multiply this value by 0.89. You are going to multiply this value by 0.89 and then you will get this formula, that is of PU. This is for axially loaded column. Now go for axially loaded with uniaxial moment. Then you should be in position to explain these curves. So on this side we have mu upon FCK BD square. What is D? The dimension which is bisected by the axis we have considered. This is Pu upon FCK BD and these all values are P upon FCK. Now you can see we have this value, maximum value. We have, this is 0, 0.02468, 0.1, 0.12, 0.1416, 182, 0.24, 22, 24, and 26. So we have till P by FCK maximum value we have 0.26. Now how we will go for this? So now you have given value of PU, you have given value of FCK, you have given value of B, you have given value of D, you have given value of MU, and in this case you have to find value PU upon FCK BD. You have to find mu upon FCK BD square. Knowing these two values, we have to plot these values, plot values on chart. We have taken problem in the class, just go through it. So suppose we have this PU upon FCK BD is 0.8. MU upon FCK BD is 0.05. Then how we will go for this? Then just I will show you here. So we have now exactly I cannot see. So let us we have 0.5 over here. So I will draw 0.5 vertical line till 0.8. So or above it. So this is line of 0.5. And then 0.8, I have to draw horizontal line. Now you can see this is over here. So very close to this curve. So this curve we have 2, 4, 6, 8, 2, 4, 6, 8, 1, 1.2. And then we have this as 1.14. So we have 0.14. So P by FCK 0.14. So P 0.14. Suppose FCK is 20. Then into 20. So we have 2.8%. And this is percentage of AG. And then as we know P value, AG value, we can find P. P we have calculated, then ASC we can find. So this is percentage. So 2.8 upon 100 into AG, we will get ASC. And then in the same fashion, you have to select number of bars and lateral ties you have to go for. In last example also, lateral ties. So bar diameter we know 6 mm, or another criteria we have longitudinal bar, maximum longitudinal, just go through is longitudinal bar upon I think we have 4. Just go through it. This is bar diameter. And then spacing we have 3 criterias. So we have 16 into D, diameter of bar. Second, we have least lateral dimension. Least lateral dimension, whichever is less. And third, we have 300. So likewise, you have to write. So same step you have to write in axially loaded also. Now in next we have that is axially loaded with biaxial moment. Now in this, we have to first find out value of MUX, value of MUY. These values are given, but we have to find with minimum eccentricity L by 500 plus B by 30, L by 500, sorry, D by 30, L by 500 plus B by 30, and these values we have to multiply. This is for MUX. We have this value that is EX, EY, and then multiplying this PU into EX, PU into EY, and these values, if MUX and MUY, these values are given. And we are going to find these values of eccentricity. And again, these values we are going to get again MUX, I will write it as MUX, MUY. This I will write M dash UX, M dash UY. And you have to take maximum of MUX and M dash UX. And this we will say it as maximum of these two, that I will write it as MUX, not this value. Maximum of these two we are going to consider MUX. maximum of these two, MUY. These are maximum values. Then we are going to find out, just I have shown you MUX1 and MUY1. How we will find these values? So let us, we know PU. We are going to assume P by FCK, from which we are going to find, we are going to assume percentage reinforcement. If not given, then find P. After finding P, you have to go for P by FCK. Now we know values of, we have taken problem in the class, go through it. We know PU upon FCK BD. We know P by FCK. And from this, you have to find MUX1. And then you have to find MUY1. Their bisecting depth. Bisecting depth. So B equal to D. Bisecting width. Bisecting width. And then from this find MUX1, MUY1. Then find alpha n. Already we know that curve. How we will find alpha n? So we have this value, this curve, you have to show it. So we have this is 0.2. For this value is 1. Then we have this as 0.8. Value is 2. And then in between we have to find this value. After 0.8, this is 2 constant. Before 0.2, it is 1 constant. And in between, we have to use similar triangles and find this value of alpha n. Knowing all these values, we have to check provided column is safe or not. MUX upon MUX1 to the power alpha n plus MUY upon MUY1 to the power alpha n. This value should be less than or equal to 1. So likewise, we have to go for this values. So this value we have PU upon PUZ. This value we have PU upon PUZ. Now PU that is given. And PUZ we have to find using the formula 0.45 FCKAC plus 0.67 FYAC. So likewise, you have to go for design of column actually loaded with uniaxial, axial loaded with biaxial. Now this completes your term work questions. Now you prepare it properly. Now I am not going to upload any of the video. You have to go through book also. Just go what we have done fastly so that you will understand in detail. So now I will stop here only. So these questions, these are from my side. Whatever questions will be asked by examiner, that is by external examiner. That I cannot say. So now we will stop here only. Thank you.